Okay guys, so here's one of our first examples for this centripetal force or centripetal acceleration idea. So once again, if anything is moving in a circle, it is always pointing to the center. So if this is a circular arc going on right here, the acceleration will always point to the center and the velocity will be perpendicular or tangent to this guy here. This particular problem asks for the centripetal acceleration. I know that the centripetal acceleration is equal to v squared over r. And so it looks like we are given the velocity. We have the velocity at 65 kilometers per hour. The radius is 95 meters. It looks like we need to convert this a little bit. So we'll convert the meters, kilometers to meters. And then the hours to seconds. So it looks like my new velocity is about 18 meters per second. And we're just going to go ahead and plug that into our centripetal acceleration. For v squared over r, I have 18 meters per second squared over the radius of 95 meters. So that gives me about a centripetal acceleration of 3.4 meters per second squared. And once again, it's always directed towards the center of the circle. All right, so this is how you do a pretty straightforward centripetal acceleration problem. Okay, thanks.